The following information relates to Walsh Limited. Budgeted production is 20,000 units per annum, which is 1,600 kilograms. All right, so if 1,600 kilograms is 20,000 units, that means 1 unit is 0.08 kilograms. And if you aren't happy with that calculation, just look at it logically like this. 20,000 units multiplied by 0.08 kilograms per unit gives me 1,600 kilograms. The standard input for 10 kilograms of output is as follows. All right, so if this is 10 kilograms of output, and we know that each unit is 0.08 kilograms, that means that this information is for 125 units. All right, so all of this information that you're going to be provided with is for them to produce 10 kilograms or 125 units of output. All right, so they need 7.5 kilograms of material A, which has a cost of 675,000 Rand, and they need 5 kilograms of material B, which has a cost of 300,000 Rand. So what you need to notice over here is they are inputting 12.5 kilograms into the production process. But when they input 12.5 kilograms of material, that is only giving them output of 10 kilograms. So there are losses in the production process. And you can see that's confirmed just below. A standard loss of 20% of input material is expected to occur. So when they input 12.5 kilograms into the production process, a standard loss of 20% is expected to occur, leaving them with output of 10 kilograms, which is confirmed just above, over there. Material A and B can be used interchangeably. So remember, that means that the usage variance can be split into a material mix and yield variance. So in this question, we will be looking at the calculation of the material mix and yield variances. $22,000 units were actually produced. All right, so if 22,000 units were actually produced, and each unit weighs 0.08 kilograms, that means, if you multiply that out, they actually produced 1,760 kilograms. 1,265 kilograms of material A were purchased for 89,000 Rand per kilogram, and 1,035 kilograms of material B were purchased for 62,000 Rand per kilogram. No inventory of materials is held. All right, so if no inventory of materials is held and they purchased 1,265 kilograms of material A, that's what they purchased, that was also used in production because there's no inventory of material. And the same applies to material B. That's what they purchased, and that was also used in production. Okay, because we don't have any inventory. Now, before we get onto the ratio calculations, I want you to first make sense of the information that's been provided in this question because we are dealing with losses in the production process. Now, you'll see just below I have a block where we are going to make sense of the information provided. I've already been through the first few calculations with you. We've done already a lot of those calculations when we were reading through the information. What's important is I want to pick up from here. Okay, we know that a standard loss of 20% of input material is expected to occur. We were told that in the question. We calculated that output is 1,760 kilograms. So if you go just above, you'll remember, that's where we calculated our output over there, all right? So if that's the output and a normal loss of 20% of material input is expected to occur, we can work backwards to calculate what they should input into production. And we do that as follows. Look at this as percentages. What they input is 100%. There's then a normal loss of 20%, leaving an output of 80%. All right? So if we are working backwards over here, we know that the output, which is 80%, is 1,760 kilograms. And remember, the maths logic is always you multiply by what you want and you divide by what you've got. Okay? So you take what you've got. What have we got? We know what the output is in kilograms. We've got the output in kilograms, all right? So you take that, the output in kilograms. You multiply by what you want. What do you want? I want what my input is. I'm trying to work backwards to calculate the input. I want the input. So multiply by what you want. Divide by what you've got. What have you got? You've got the output. You were given the output, or we calculated the output. So you've got the output. So calculate or work backwards and calculate what should have been input in order to achieve an output of 1,760 kilograms. All right. And you can see the proof is just below if you aren't happy with the calculation. They should input 2,200 kilograms because a normal loss of 20% is expected to occur. And that will then leave you with output of 1,760 kilograms, which is what we calculated the actual output is. So to achieve that actual output, they should have input 2,200 kilograms. That's what they should have input in order to achieve an output of 1,760 kilograms. However, what did they actually input into the production process? They actually input 1,265 kilograms of material A and 1,035 kilograms of material B. That's what they actually input. In total, 2,300 kilograms. So we can now see we have an abnormal loss of 100 kilograms. And we calculate that by comparing what they actually input, so they actually input 2,300 kilograms into production, compared to what they should have input. They should have only input 2,200 kilograms if they were trying to achieve an output of 1,760 kilograms. So compare what they actually input to what they should have input, and that will give you your abnormal loss. And you'll see that can then be reconciled. So take the actual input. They actually input 2,300 kilograms into production. We calculated an abnormal loss of 100 kilograms. I'm going to prove to you through the next calculations that we look at, this abnormal loss over here is your usage variance. So with the calculations, I'm going to prove to you that the standard always takes the normal loss into account. So if the standard always takes the normal loss into account, any usage variance that you calculate is going to be an abnormal loss. And I'm going to prove that through our calculations. So let's just finish this recon quickly. They actually input 2,300 kilograms. We calculated that above. That's what they actually input. We also calculated that there's an abnormal loss of 100 kilograms because they input more than what they should have input. So 2,200 kilograms is remaining. We know that there's a normal loss of 20%. So if you deduct the normal loss of 20%, that leaves you with output of 1,760 kilograms. You can just see how everything's tying into all of our previous calculations. And we know if we want to calculate the number of units, we just need to divide by the number of kilograms per unit, and we get the number of units. So once again, guys, you can see everything now should be slotting into place. All of these numbers here tie in to all of our previous calculations. You can see how everything works. Okay, so that's how losses work in the production process. And this isn't standard costing, guys, but I included this example because I think it's important for you guys to understand how losses work because I don't think you really do. So hopefully this example shows you this is how losses in the production process work, and now when we actually look at the variance calculations, everything should make a bit more sense and you're rather focusing on logic instead of memorizing formulas, etc. Think logically with this stuff. We are now going to calculate all possible material variances. Now you'll see I have the formulas in the lecture notes for you, but I want you to apply a logical approach instead of just studying formulas. So I'm going to answer this question as I expect you to answer any standard costing question that you get. As soon as I see that I need to calculate all possible material variances, I'm going to write down my formulas. In RAF, very quick because there's no marks allocated for formulas, but you do this to prevent making silly mistakes. So I see straight away, calculate all possible material variances. So I go, okay, what is the logic that I follow? Because we follow logic, we don't study formulas. The logic approach is, you always start with the actual. So for material, that's going to be the actual price multiplied by the actual quantity. You always start with the actual. We change one thing at a time. First, we change the price. And by changing the price, that leaves us with a price variance. Then, keep the price the same, just change the quantity. And that's going to give you a quantity or a usage variance. Now in this question we know there are two different types of material that can be used interchangeably, which means the usage variance can be split into a mix and a yield variance. So what we do is we just repeat this. So just repeat this. And you'll see when we get to our labor calculations, we follow exactly the same logic. So the same logic always applies. Repeat that. Now, the only difference between these, this is the actual quantity in the actual mix. And this is the actual quantity in the standard mix. All right. So, only one thing changed. The standard price is the same, so that information over there is exactly the same. We've changed one thing. This is the actual quantity in the actual mix. This is the actual quantity in the standard mix. So we are comparing the actual mix to the standard mix. We've only changed one thing, the mix. So this is going to give us a mix variance. All right. Then over here, the price is the same. So we're keeping the price the same. The only thing we're changing is the quantity. We are comparing the actual quantity to the standard quantity. So that's going to give us our yield variance. All right, it's a quantity variance, guys. The terminology is just, the correct terminology is, this is a yield variance. All right. So you quickly write that out. Look how quick it was to write that out, and you follow a logical approach. Now I know these are all of the variances I'm going to calculate, and these are all of the formulas that I'm going to use. Okay, so you're not studying formulas, you're following a logical approach. Then something that's always very important to note, this price variance over here. Remember your usage variance, meaning your usage, your mix, and your yield variance. All of these calculations will always be based on the quantity of material that's used or issued into production. However, with the price variance, if inventory is valued at standard cost, then the price variance is based on the quantity purchased. However, if inventory is valued at actual cost, then the price variance is calculated based on the quantity used or issued into production. That's really the only other very important thing that you need to know. If you know that, if you have that information in your head, and one other important thing. We started this lecture by saying whenever we calculate variances, we always compare the actual result to the flexible budget. We never compare the actual result to the original budget. So please note this standard quantity over here in all of your calculations will always be flexed to actual output. Because we always calculate variances by comparing actual results to flexed budgets, not original budgets. So this must be flexed to actual output. All right, so let's look at the variance calculations. First, we are going to look at the material price variance. So there's your formula, and it comes from the logic that we just looked at. You don't need to write the formula out again. I've got the formula just so that you can see how it ties into the logic, but you've already written down the logic. You've got all of your formulas. You can jump straight into the calculation over here. But we calculate the price variance by comparing the actual price and the standard price. The quantity remains the same. The only thing that I just want to add here is this is the actual quantity in the actual mix. All right, you'll see that ties into what we just wrote down. All right, so for both material A and material B, we need the actual price, the actual quantity, and the standard price. All right, so let's just clean this up a bit over here. So for material A, the actual price is 89,000 Rand per kilogram, and the actual quantity is 1,265 kilograms. For material B, the actual price is 62,000 Rand per kilogram, and the actual quantity is 1,035 kilograms. We then need the standard price per kilogram. Now just be careful, these costs that you've been given are not the standard price per kilogram. That is the standard cost in order to achieve an output of 10 kilograms or an output of 125 units. It's not the cost per kilogram. But we can easily calculate the cost per kilogram just by taking the cost and dividing by the number of kilograms. You then have the standard price per kilogram. So you'll see that's one of the upfront calculations that I perform over here. Oops, I calculate the standard price per kilogram over there. All right, so I've spoken you through where all of these numbers and amounts come from. Let's just look at the logic behind the calculation. So you can see the actual quantity is exactly the same. If we are looking at material A, the actual quantity is the same. We are comparing the actual price paid per kilogram to the standard price per kilogram. And you can see they actually paid less than the standard price, and that's why the variance is favorable. Let's look at material B. You can see the actual quantity is exactly the same because we are calculating the price variance. So the quantity is the same. We are comparing the actual price paid per kilogram to the standard price per kilogram. And this variance is unfavorable because they actually paid more than the standard price per kilogram. All right, so that's your material price variance. Then we calculate the material mix variance. Now, this variance starts where the last variance ended off. So the last variance ended with the standard price multiplied by the actual quantity in the actual mix. So that's where this variance starts. And then if you go back to your logic that we wrote down, we are comparing this to the standard price times the actual quantity in the standard mix. So everything's the same. The only thing we're changing is the mix, which means this is going to give us a mix variance. Okay, so this is the standard price multiplied by the actual quantity in the standard mix. You can see the only difference between the two is this is the actual mix and this is the standard mix. Everything else is exactly the same, so this gives us a mix variance. Now remember I said to you this variance starts where the last variance ended. So go back. We already have the standard price multiplied by the actual quantity in the actual mix. So just bring those amounts down. Now you just need to be careful whenever you bring these amounts down. I just want you to consider one thing always so that you don't do this without thinking. In this example, you were specifically told that for material they don't hold any inventory. So the actual quantity purchased was the same as the actual quantity used in production. So we could just bring the amount down without having to think. However, just remember, if you are faced with a situation where there is raw material inventory, so let's say, for example, they buy 10,000 kilograms, but they only use 8,000 kilograms in production. So there's 2,000 kilograms sitting in raw material inventory. And remember, if you are told that your material inventory is valued at standard cost, that means that this price variance is going to be calculated based on the actual quantity purchased, okay? So then you can't just take these quantities down, because your usage variance, remember the mix variance is part of your usage variance. Your usage variance is split into a mix and a yield variance. So the usage variance, or this mix variance, is never calculated using the actual quantity purchased. It's always based on the actual quantity used in production. So then you just need to be careful of just carrying those amounts forward. All right, so if you are carrying amounts forward, always just make sure that this actual quantity over here is the actual quantity used in production and not the actual quantity purchased. Then we need the standard price multiplied by the actual quantity in the standard mix. So you already have the standard price, so you can just carry that forward. That's your standard price per kilogram. We now just need the actual quantity in the standard mix. So if you go back to the upfront calculations, here's my calculation over here. All right, first guys, the actual quantity in the actual mix, that comes directly from the information provided in the question. They actually used 1,265 kilograms of material A and 1,035 kilograms of material B. That's what they actually used in the actual mix. In total, they actually used 2,300 kilograms. Now we need to take that same actual quantity. So you can see the actual quantity in total doesn't change. We are taking the same actual quantity, we are taking the same actual quantity and we are now just putting it into the standard mix. So, where does the standard mix information come from? Here's the information relating to your standard output. In order to achieve this standard output of 10 kilograms or 125 units, this is what is required to be input into production. So, based on this information that we've been provided with over here, we know that when 12.5 kilograms of material are input into production, 7.5 kilograms should be material A and 5 kilograms should be material B. That is your standard mix, all right? So using that information, we calculate the standard mix as a percentage. So that means 60% of all material that is input should be material A, and 40% of all material that is input should be material B. That is what the standard says, all right? So now we just take this actual quantity and we put it into that standard mix. We multiply by 60% and we multiply by 40%. So that's the only other calculation you need to do. You take the total actual quantity and you put it into the standard mix. Okay, so that's where that comes from. That's your actual quantity in the standard mix. So for material A, they actually used less than what they should have used, and that's why the variance is favorable. For material B, they actually used more than what they should have used, so this is unfavorable. And overall, the total mix variance is favorable. And the reason why it's favorable is because they are using more of the cheaper material, which is material B. You can see material B is much cheaper than material A. Material A is more expensive. So they're using more of material B, which is the cheaper material, less of material A, which is the more expensive material, and that's why overall the variance is favorable. Then lastly, we just need to calculate the material yield variance. And once again, this variance starts where the last variance ended. So save yourself time. You have already calculated the standard price multiplied by the actual quantity in the standard mix. So just bring that down. We now need to calculate the standard price multiplied by the standard quantity. And please remember, this standard quantity is always flexed to actual output. All right, so we already have the standard price for material A and also for material B, so you've got the standard price. So we actually just need to take the standard quantity and flex that to actual output. Now, this is how you perform this calculation. I actually don't need to write this down. If you just look below, you've got two choices. Let's look at the first option. You take the standard quantity in order to make 1 kilogram of output, and you multiply that by actual output. But because you are working with the standard for 1 kilogram of output, you need to multiply by actual output in kilograms. All right? So let's look at the calculation. Go back to the information provided in the question. In order to make 10 kilograms of output, they need to input 7.5 kilograms of material A. So that's what they need to input in order to make 10 kilograms of output. How many kilograms did they actually produce? 1,760 kilograms. So that's how we perform this calculation. According to the standard, they should input 7.5 kilograms in order to make 10 kilograms of output. So just divide that by 10 so that you get the standard quantity for 1 kilogram of output, because the 7.5 kilograms is for 10 kilograms of output. We want the standard quantity for 1 kilogram. So just divide by 10. And then you need to multiply that by actual production in kilograms, which is 1,760 kilograms. Now, as an alternative, what you could have done is taken the standard quantity for 1 unit of output and multiplied that by actual output in units. And you are multiplying by actual output in units because you are working with the standard quantity for 1 unit of output. So go back to the information provided in the question. We know that output of 10 kilograms is 125 units. So that means they need 7.5 kilograms to make 125 units. So we don't want the standard quantity for 125 units. We want the standard quantity for 1 unit. So we're going to say 7.5 divided by 125 so that we can get the standard quantity for 1 unit instead of the standard quantity for 125 units. And then you need to multiply by actual production. And because we have the number of kilograms that are required for 1 unit, we need to multiply by actual production in units. So just be consistent and follow a logical approach. It doesn't make sense to half work with information in kilograms and half units. Be consistent always. Follow one consistent approach. So I've shown you both alternatives. Obviously, whichever one you prefer, you work with what you prefer. All right, so the yield variance for material A is unfavorable. And that's because if they actually produced 22,000 units, they should have used 1,320 kilograms. They actually used 1,380 kilograms. So because they actually used more than what they should have, the variance is unfavorable. Let's look at material B. If they actually produced 22,000 units, they should have used 880 kilograms of material B. They actually used 920 kilograms. So because they actually used more than what they should have, the variance is unfavorable. All right. Then, in order to calculate the usage variance, it's the sum of your mix and yield variance. So just bring together the mix and yield variances that were calculated previously. Obviously, if the one's favorable and the other one's unfavorable, then you need to deduct and calculate the difference. So overall, we have a total material usage variance of 4.35 million rand unfavorable.